Okay, I'm going to go over an introduction to arguments, or some parts of it. You should have this printed out and you should read it. So let's see. I'm going to assume that you've read 1.1 and basically understand it. So I'm not going to go over what an argument is. I'll assume you know that. Premises supporting a conclusion, and that you know what an argument looks like. So I'm going to start here in 1.2, and I want to go over both of these definitions, which are given on page 5. Okay, so we'll start with the definition of deductively valid. An argument is deductively valid when it is the case that if the premises are true, then the conclusion has to be true. Okay, so two things to note about this definition is, one, we're just saying if the premises are true. We're not worried about whether or not the premises are in fact true. We're just interested in if they are true, then what does that mean for the conclusion? For an argument to be deductively valid, it has to be the case that if they're true, then the conclusion has to be true. All right, then you have two other ways of wording the same definition down here in the very bottom of page 5. So you might want to look at those. But right now, we will go over some examples. Okay, so we'll start with this one. Seoul, South Korea is larger than Mexico City. That's premise 1. Premise 2, Mexico City is larger than New York City. Conclusion, therefore, Seoul is larger than New York City. Okay, this argument is valid. And the reason it's valid is because if these two premises are true, then this conclusion has to be true. Okay, next, it is either warm outside or cold outside. That's premise 1. Premise 2, it is not cold outside. Conclusion, therefore it is warm outside. Okay, this is also valid. And it's valid because if these premises are true, then this conclusion has to be true. Okay, so you might notice about these two arguments that they have a certain form that makes them valid. So any argument that has the form A is larger than B is larger than C, therefore A is larger than C is going to be valid. Similarly, over here, any argument that has this form, A or B, not B, therefore A is going to be valid. Okay, let's look at these two. So Mary is a cold-blooded animal. All cold-blooded animals are lizards. Therefore, Mary is a lizard. Okay, so this is valid. All cold-blooded animals are lizards, according to premise 2. Mary is a cold-blooded animal, so therefore it has to be the case that Mary is a lizard. Now notice in this case that premise 2 is false. It's not just lizards that are cold-blooded, but we don't care about that when we're evaluating whether or not the argument is valid. All we care about is if these two premises are true, what does that mean for the conclusion? Okay, this is a very similar argument. This is also valid. Barack Obama is a man. All men are warm-blooded animals. All men are warm-blooded. Therefore, Barack Obama is warm-blooded. Okay, in this case, the premises happen to be true, but for evaluating whether or not it's valid, that doesn't matter. Again, it's just if they're true, what does that mean for the conclusion? In this case, it has to be true. All right, let's go up to this one. Okay, so here we have 3 premises. Premise 1, there is a bridge in your town that hundreds of cars drive over every day. Engineers who work for the town regularly inspect the bridge. Every once in a while, repairs are made to the bridge. Therefore, this bridge will be safe to drive over tomorrow. Okay, that's the conclusion. Okay, so if these premises are true, does the conclusion, the bridge will be safe to drive over tomorrow, does the conclusion have to be true? And here the answer is no. These premises can be true and the conclusion can be false. It might happen that tomorrow the bridge breaks. Okay, so this argument is invalid. Okay, so let's go back to page 5. All right, now we have this other definition. This is a definition for inductively strong. So an argument is inductively strong when it is the case that the argument is not deductively valid, that is, it's invalid, and if the premises are true, then they make it probable that the conclusion is true. Okay, and you also have some different ways of wording that definition here on the bottom of page 6. Okay, so this argument we said was invalid. It's also, however, inductively strong. So if these premises are true, then they make it probable, very probable, that this conclusion will be true. It's not guaranteed that the conclusion will be true, but it's very likely. So the argument is inductively strong. Okay, next, this one. Premise 1, Peter is a human 12-year-old and he can breathe underwater without any artificial aids. Both of Peter's parents can breathe underwater. All of Peter's aunts and uncles can breathe underwater. All of Peter's grandparents can breathe underwater. Peter's older sister can breathe underwater. Therefore, Peter's younger brother will be able to breathe underwater. Okay, so if these premises are true, in this case we have 5 premises. If the premises are true, does the conclusion have to be true? No, so the argument is invalid. But if these premises are true, is it probable or even very probable that the conclusion will be true? There the answer is yes, so the argument is inductively strong. Okay, then finally, we'll look at this one. In every U.S. presidential election since 1852, either the Democratic candidate or the Republican candidate has won. That's what we just have one premise. And our conclusion is, therefore, the Democratic candidate or the Republican candidate will win the, well, it should be 2024 U.S. presidential election. Okay, so this argument, again, is invalid. If this premise is true, the conclusion doesn't have to be true. But the argument is inductively strong. If the premise is true, then it's very probable that the conclusion will be true. Okay, so I'm going to stop there. In the next video, I'll talk about the 2 definitions that are in section 1.3.